Hello guys, welcome back to the another part of C++ complete game series of Unreal Engine 5, a supermarket simulator. In the previous lecture, we have successfully created a new input action and bound the action to the callback function of moment. In this moment function, we have retrieved the input values and displayed it on screen. Now it is time to use that input value to actually move the player. Let's get started. I'm gonna head back to Visual Studio, then in my character, let's go to player character. We already have defined the input action for look, so we don't need to change anything here. And yeah, let's create a new callback function for look. We're going to copy the move input action. I'm going to rename it to on look input action. And I think there's no more changes required in add a file. I'm going to create an implementation for this callback function. Okay. Actually, before this, we need to, yeah, we have created the callback, but before getting into look, let's finish off the moment code. So here we got the input value. We have changed it from f input action value to vector 2D, where we retrieve forward and right or left direction. Okay, so we need to calculate direction here. Yeah, so we need to get the forward direction of player, which will be the yaw direction. So let's use F rotator, and already the Visual Studio is suggesting me the required changes. I'm going to name it movement rotation with the default value in role is 0.0f, and in pitch I need controller. And there you go, the Visual Studio is already giving me the suggestion. Get controller, sorry, we need to get control rotation, not controller, control rotation. It's a method dot yaw, and then 0.0f. We don't need to change anything in either x, or I mean in role or yaw. Now before actually doing this, we are using controller, so it is always best practice to check if controller is valid. If controller, because sometimes there might be a chance where a controller is null and the Unreal Engine will crash. So to prevent that crash, we are going to validate if controller is valid. We don't need to specifically use is valid or anything like that, because Unreal Engine already has an internal function where if you just write if any U object, it will directly check if it is valid or not. It is just a pointer, right? So it will by default check everything. Now we have finished the validation. We got the input action, sorry, input value. Then we got direction, and we are already checking if it is not null, the input value. Now let's remove this debug function. Now let's calculate the actual forward direction. This is the movement direction, which is current player's movement direction. We need current player's forward direction. So let's use const f vector direction equal to, you're going to use the above movement rotation, rotate vector f vector. So this is for left and right, so we are going to use right vector. Right, so we got player's right direction. If we quickly go into paint, let's say this is a player and this is the north. Let's assume this is north. And if this is north, then the player's right direction is this. Okay. And if this is not, then the right direction is this. And if in case the player is rotated, if this is north I mean the forward direction, sorry for that, then the right direction will be this side. I hope you're understanding what I mean. So whatever direction player is facing, we need a relative right direction, not a world right position, rotation. All right. So that is what we are doing here. We are getting. That's why we are using a prefixed f vector static function, where it will automatically get a relative right vector of moment rotation, which actually will point to player controller. Okay. Then we got the direction. Now very simply we use add movement input, and there you can see direction and movement move value dot x. So if you see this, we have it inherits from it is a method of a pawn, and we have two required parameters. One is direction, which direction you want to add input to, and scale value, which is the input value. We are giving that using this variable which we have created earlier, which retrieves from input action value. And yes, that's all. I mean, the right direction will work now eventually after we finish and compile. Now let's copy the same thing, paste it here. Direction, instead of right direction we want forward direction, and instead of x we want y. Yes, that's it. I'm going to hit Control S to save and Control B to build my project. I mean compile the project. Once it is compiled, we are going to hear a chimping noise. There you go. Let's test it. There you go. SDA. It's working. Congratulations. We have finished our first base mechanism of movement. Now it's time to implement a looking around feature. Let's do that. Yeah. Similarly, what we did in move function, we are going to follow the similar steps, which is we're going to check if controller is valid. Then we are going to retrieve input value from input action value structure. Then we are going to check if the value is not 0, because we don't want to repeat or we don't want to invoke the movement function even when the button is not pressed. We don't want to do that, because there will not be any difference if you invoke the function when you do not press. The only difference is the performance, because it is going to invoke every frame. So just to save the performance, we are going to check if it is only pressed. And the look is actually very easy than the move function. Let's get started. If controller is valid, then we are going to retrieve f vector 2D look value equal to value dot get. And yes, it is also a vector 2D, because we need both x-axis and y-axis, which is up and down for of mouse position, then left and right of mouse position. Yes, we got the input value. Then we are going to check if look value dot x not equals to 0.0f. Then we're going to do same for y-axis as well. It is just a simple single line of code. add controller yaw input for the x-axis. Yaw is actually up and down direction. Look value dot x, then add controller yaw in, sorry, it is pitch. We need to use pitch for y-axis. Add controller pitch input. Look value dot y, and that's it. I think we need to bind it, correct. Let's do that. I compiled it. It will compile without any error because we are not actually invoking this function anyway. Let's create, let's duplicate the same line, and here I'm going to change it to look. Did we create one? Yes, we did. We want this to be triggered as well, and then on, sorry, on look input action. I suppose this is right. Let's compile and test. Let's go. There you go. You can just move around wherever I look. I'm only pressing W and then I'm rotating. That's it. And okay, next we're going to implement sprint, which is running and walking, two different walk speed. Let's do that now. Firstly, let's head back to data collection, not the CPP, or data asset input data collection. Let's create a new input action for sprint. Sprint action. We have created that. Let's create a callback function. On sprint input action, that's right. Let's create an implementation too. There you go. And we need one, three variables. One will be private. We do not want this variable to be exposed to Unreal Engine. It is just a local variable. It is a boolean is sprinting, whether to check if the player is currently sprinting or not. And two variables. Let's copy this U property. I'm going to change this to player because that is player settings. This will be float walk speed. Now I'm going to copy this, and this will be sprint speed. Once I'm going to compile to see if there are any errors. There shouldn't be any. All right. Now, firstly, in the begin play, there is no begin play because we have inherited from another class. Let's override begin play in protected, just like we did it here. Virtual void begin play, and we need to mark it as override. I want to create implementation. All right, first we are going to call super begin play, not the player. All right, so what is super? Super is actually when a class is inherited from another class. Let's say this is class B and this is class A. Class B is inherited from class A, and if you want, if when you're overriding a method or any when you're overriding a method in class B and you want to also you implement the functionality of the same method which is written in class A, then you're going to access is using super. So what do we have in character base begin play? Let's go to CPP. There isn't any, but let's say there is some basic functionality. Obviously we are going to have so much functionality later on in this course. So even though the player or a customer, as we have discussed in the character architecture, Both might have common functionality that will be written in here. So we need both player characters or customer characters and also common functionality that will be executed here. So we call it using super. So that goes that. Let's close character base. We don't need anything as of now. All right, in begin play, let's set current player speed, get character movement. That should be an arrow operator. Max walk speed equal to walk speed. So at begin play, we are making sure the player getting started with walk speed. Okay, we need to include character.h, include game framework slash character.h to be able to use that. This shouldn't come up. So we need to include game framework slash character movement component. There you go. And Visual Studio really helps me sometimes. There you go. The error is removed. To make sure there's no error, we can just compile it. That's a successful compile. Yeah. So we have set the player speed to walk speed at the beginning of beginning of play. Now let's set this print functionality. So first of all, in any input action, we are going to retrieve the input value from struct. That will be bool. This is another local variable is printing equal to value dot get. We are going to get type bool because it's just a boolean whether the key is pressed or removed or released. That's all we want. We don't want while holding or anything. And it's not a vector 2D like move or look, because we need only one simple action whether it is pressed or not pressed. So most basic is the boolean right now. So if is sprinting, we want to set get character movement max walk speed. So when it is pressed, we want that to be sprint speed. If it is not, we want that to be walk speed. We are going to set walk speed and sprint speed in Unreal Editor because we have exposed with the U property. Yeah, so that's it, and we need to change it. Let's go is sprinting should be true here. You don't actually need to do, but yeah, so let's bind the action now. I'm going to copy this 2 times. Sprint. One is triggered. No, started. We want one to be started and another to be completed. For both, it will be on sprint action input. All right, let's compile. That's a successful compile. Let's open a character. Oh, sorry. That should be in blueprints, character, player, BP, player, character. Here it should be in player. Correct. I researched and while testing, I like the default walk speed of 300 and sprint speed of 525. Let's test. So the player is walking now. Okay, so it's not working. Let's see what's wrong. I know what that is. We need to go into input, input action. Yep. So we can use jump from default action. We'll rename it to sprint. So it is already in Boolean, and we have two triggers, which is press and release. That's exactly what we want. And here sprint. Let's go back to add new mapping in the input context. Sprint. The button should be shift, left shift. Now it should work. There you go. The player is walking, running. And I release the button again, walking. So yeah, we have finished movement, looking, and sprint. That's it for this lecture. In the next lecture, we are going to introduce a new feature called as interaction. Using this system, interaction system, we are going to interact with other actors such as door, computer, or any interactable actor. Thank you for watching. Stay tuned for the next parts.